Welcome to our fourth and final video for Lesson 7-4. As promised, we're going to take a closer look at an example of a decay problem. Now, just to refresh your memory from the previous videos, we talked about how we have the compound interest formula, and that is A equals P times 1 plus R over N raised to the N T power. This was our compound interest formula. We talked about how we could convert this into our exponential growth formula. We do the same thing to change it into our decay formula. The only difference is, since we are losing value instead of gaining value, is we are going to put a subtraction sign instead of a plus sign, but we're still going to plug in a 1 for our n in both places. So when we simplify this, it ends up with A equals P times 1. R divided by 1 is R, and 1 times T is going to be T. So that is going to give us our decay formula. Again, this is not given to you on the formula sheet, but it is something that you have a little hack to go ahead and figure out. So let's go ahead and look at example 5. We are told that a car is purchased for $24,500. We're told that it will depreciate at a rate of 18% for the first 6 years. Now, we're asked first, is this going to be exponential growth or decay? If you don't know what depreciate means, it means that you are losing value. When you buy a car, the minute that you drive it off the lot, you instantly lose value from what you paid for it. It's going to be automatically worth less. And the longer you have that car, the less and less it's going to be worth. So this is actually going to be a decay problem. I just want to take a moment to do a little short brainstorming list of some of the words that might help you tell whether something is growth or decay. Like I just said, if you see the word depreciate, that is going to be a decay problem. The opposite of depreciate is to appreciate, and that means to gain in value. That's going to be a growth problem. Alright, another word that you might see for growth is increases, and the opposite for that, for decay, would be decreases. Sometimes you might see words as simple as grow and decay. Another thing for grow, gains or increases, we've already said. This is not a definitive, exhaustive list, but it is going to give you something that helps you kind of tell between the two. You can add words to that as you go through the lessons and pick up other little clues like that. So we are asked to identify the initial amount. That is going to be the $24,500 that you initially pay for the car. We're asked for the growth decay or the growth factor. Now this is a little bit tricky. Remember, back to our vocabulary, the factor is actually the 1 plus the R or the 1 minus the R. Since this is decay, this is going to be 1 minus the R. Our R was the 18%. We need to change that to a decimal, so we move the decimal over 2 places. It's 0.18. We go ahead and subtract these, and that is going to give us 0.82. Now we're asked to write an equation to represent the loss in value. So we're going to pull together as much of this information as we can. We don't know what our amount is going to be. That's what we're going to have to figure out. P is going to be our starting value, so the 24,500. Our R value is going to be 0.18, like we said earlier. N in any decay problem is going to be 1. That's how we changed it from the compound interest formula to the decay formula. And then our T for this, it looks like it's going to be 6, but let's see what we're actually asked for in other problems. We'll go ahead and plug into the formula what we do know. We are looking for A. Our P is 24,500. We're doing 1 minus our 0.18 this time. Because this is decay, we're decreasing. And we'll just put to the T power right now. I know it said for the first 6 years, but you'll see we're actually going to be asked for a couple different values when we get to the next page. Now, we would go ahead and simplify this. A equals 24,500. And then we would do the 1 minus 0.18, which is going to give us 0.82. And you'll notice that we're seeing our growth factor appear. So let's go ahead and see what they want us to do next on the next page. It says, according to the small, approximately how much will the car be worth after 2 years? So I'm going to rewrite my equation that I just wrote on the other page. 24,500 times 0.82 raised, and our t is going to be 2 this time because we want it after 2 years. Again, if you're confused where we got this formula, just scroll back and it was on the end of the last page of notes that we did. Now again, we will just type this into our calculator. Be careful that you are putting everything in exactly as you see it. And that is going to come out to be 16,000, misplaced my comma there, $16,473.80. Let me just double check that real quick. Alright, that was right. I just wanted to double check it when I had it written down on my notes. I didn't have the 0 written down, but it does come out to be exactly 0.80. So it will be $6,473.80. Now the next question is an interesting question. We're asked, after how many years will the value of the car drop between $10,000? Now, we don't really have a good way to solve exponential equations at this point, and we're really not going to get into solving any that are this complicated in Algebra 1. Once you get into algebra, advanced algebra, after you take geometry, you will start looking at some things called logarithmic functions that will help you to solve these exponentials. Right now, we don't have those tools in our tool belt, so we're going to have to use an old tool back from probably first seen in elementary school of guessing and checking. So we want to know, after how many years will the value of the car drop below $10,000? So we already have a baseline of 2 years from our last problem. At 2 years, it's going to be $6,473.80. Alright, the next thing we would want to do is, let's just go ahead and try 3 years. So for 3 years, we would use the exact same formula that we used above, and we would put the 0.82. The only difference is, instead of 2, we'll plug in a 3. And let's see what we get. When we plug that into our calculator, we're going to get 13,000, and I left off the 1 from up here, sorry. $13,508.52. So we're still not below that $10,000 mark. So that means we need to try again. Let's try 4 years. If we plug in for 4 years, we're going to do 24,500 times 0.82 raised to the 4th power this time. And that is going to give me $11,076.98. So we're getting closer. So let's go ahead and do it one more time. We'll plug in 5 years, and we would plug in 5 this time for our t value, 0.82 raised to the 5th power, and that is going to give us $9,083.13. So that is the first time that it dips below $10,000. So we would say that it occurs between year 4 and year 5. And we have our final answer. Alright, you guys have one last you-try problem. Go ahead and give it an attempt. Make sure you check it. Go ahead, do your practice. Let us know anything we can do to help you out. Then get ready for that master check. Alright, see you guys later.